will have a couple of options from which you have to select the thing. It is an online quiz. Okay, and the quiz will be taken in the Canvas platform. All your materials are also available in the Canvas platform, and the quiz will be taken in the Canvas platform. Till now, every day we are sending repetitively to your email to join the Canvas platform. Okay, whatever we have observed that in this entire FDP, about including all the academies, there are 470 participants are there. Okay, out of which 130 have still yet to join the Canvas. So 130 is a very huge number. Without joining the Canvas platform, you cannot able to appear for the quiz. And without appearing for the quiz or examination, it will be difficult for us to issue the certificate. So it is request for all the participants that you join the Canvas platform as soon as possible. Also, there before appearing for the main quiz, we will have just a practice quiz for you. Okay, in which very general questions will be asked. It is just there will be a mock quiz, so that we will able to access that whether participants can able to fill that quiz or not. So that is a mock type of quiz which we will be putting it. Okay, and in which there will be just 5 questions will be there. That will not, don't think that that will be required for the grading. It will be just a mock quiz, and we are starting the mock quiz today.
Yes, today 7 p.m.
Today 7 p.m. onwards we will start the mock quiz. Okay, this is just a mock quiz. Don't worry about it or its performance. Just we want to access that the participants can able to do it or not. It will be, the quiz will be available from 7 o'clock onwards till 20th February 11:30 p.m. So more than 1 day of time is given, more than 1 day of time. Anytime you can open your Canvas link and you can just click the things and complete the mock quiz. Okay, again I am saying that it is just a mock quiz, just to test that whether you can able to access the quiz perfectly, you can able to answer the quiz in a proper manner or not. So it is just a mock quiz we will be starting in the Canvas platform. So it is requested to all of you that you appear in the mock quiz, so that you can easily able to understand the pattern of the quiz which will be happening on the Friday. Okay, so we will give you entire huge amount of time to appear for the quiz, and in the Canvas platform, so as per your suitability of and there is no this mock quiz will start from today evening. Only 5 questions are there. Okay, only 5 questions today evening onwards till tomorrow. It will be there till tomorrow night. So anytime you can wish to log in, you will log in, and you can do it. Today night, while sending the materials also, we will be sending the details about the mock quiz. But when you log into your Canvas platform, you will see the mock quiz, and it will be there till 24, more than 24 hours. Okay. So I hope it is clear to all of you. Okay. So now we will start our next session. I believe my slide is visible to all of you. Okay. So and voice is also clear, I believe. So after genetic algorithm, in this particular session, I wish to share with you another very interesting algorithm that is developed in a recent interval of time, that is known as a social spider optimization algorithm, and how it is different than other algorithms that I will discuss with you, other nature inspired algorithms, and how our group has applied this particular algorithm for hyperspectral and multispectral image analysis. That application we will be discussing. So let's focus about the problem. What is an hyperspectral imaging? Hyperspectral imaging is a image that is formulated from, it is not a normal image, I can say. It is a image that is collected with electromagnetic spectrum. And where this electromagnetic spectrum will be there, it is from the satellite. If you are sending the electromagnetic uh, waves with the help of a camera or with the help of a you can able to say with the help of a antenna, and you are sending it to the surface of earth, and you are receiving the back wavelengths, then those wavelengths which are reflected back from the earth's surface, that will be collected over there, and those wavelengths which are long wavelengths, they are perceived as red color, and the medium wavelengths, they will be perceived as green color, and the short wavelengths, they will be perceived as blue color. So with this reflection from the earth's surface, the collected wavelengths, they will formulate the image. Okay. So you can observe that here in this particular image, this below blue color portion, this particular one is an image of an ocean, and here there is a river. This river is uh, getting submerged in the ocean, and in this particular portion there is hilly area, you can observe, and in this particular portion there is forest and green area. This is one particular image, and like that there are a number of images that have got stacked over here. You can observe that it is a three-dimensional cube. That means one image, then next image is stacked, next image is stacked. Like that there are a number of images we are obtaining. Why a number of images? Because of the lambda, because of the wavelengths. Okay. So the images So the hyperspectral images sensors collect information in the form of a set of images that I told you. Each image is representing a narrow bandwidth, narrow wavelength range of electromagnetic spectrum, also known as a spectral band. And these images are always combined and form a three-dimensional thing that I have shown you, that is xy and lambda. Xy represents your two-dimensional image, and lambda represents the corresponding spectrum on which the particular image is generated. Okay. One of the example is NASA's Airborne Visible Infrared Imaging Spectrometer, average, with which the NASA collects the images from uh, either from the satellite or from the aerospace vehicles. So the difference between the hyperspectral and multispectral is the hyperspectral imaging uses continuous range of wavelengths, that is 400 to 11 nanometer in a step size of 1 nanometer, that is continuous bands are stacked one after the other, whereas multiband imaging uses or multispectral imaging that uses targeted wavelength of 400 to 1100 nanometer with step size of 20 nanometer. So one image is taken at 400, then next one will be 420, 440, 460, like that. With 20 nanometer difference, the images have been taken. This is an example of various images taken from the NASA's satellite hyperspectral imaging. You can observe that these images possess very significant information like fire detection. In this A and E, you will observe that there is fire and smokes are there. Then there is glacier detection. Glacier detection is very, very important because Eskimos might be living behind the glacier, and timely we have to inform the people. Otherwise, when the glacier melts, then there will be huge problem for the human beings. They are residing below the glacier. It is very important to detect water in various remote areas or water that are present on the top of the hill or in a remote location, which you can able to observe from the satellite. Okay. And another very important application of this particular hyperspectral imaging is landscape monitoring. We wish to monitor the landscapes which are very close to the sea beach. Why? Because if there is a tsunami like condition, then those areas may get submerged in a quicker interval of time. So if we are constantly monitoring those areas, then we can look what are the changes in those areas, and we can able to inform the authority prior to it. These images will have specific things, like there are two important problems. One very important problem is image segmentation of these images. Another one is band selection. So there are huge number of bands. How can we select effective bands? And these images, how we can able to segregate them into various parts and extract meaningful information out of it. That is a challenging task. So here an hyperspectral image is bifurcated into 5 different clusters. You can observe that in this particular cluster the greenery region is there. Here only water content is there, and here only hilly surface is there, and in this particular thing only greenery is available. So like that it has been bifurcated into 5 different parts. This particular hyperspectral image has been bifurcated into 5 different portions. So the image segmentation is formulated over here as a clustering problem or grouping the pixels in a specific pattern. The one particular image can be represented as a data set of pixels, and this data set of pixel is like a p n cross d, where n is number of rows and d is number of columns, that rows and columns representing the pixel values. And we have to bifurcate this particular image into m number of groups or m number of clusters, and we can bifurcate it in such a way that none of the clusters should be empty. That means we cannot able to say that one particular segment, image segment we are making, and it has 0 pixel, no pixel is there. We cannot able to say like that. At least it should have 1 pixel value, then we can say that that is an effective partition. Okay. Then the next important thing is there should not be any common pattern between two clusters or two segments. We cannot able to say that one particular pixel, that is a pixel of water also, and that is also representing a pixel value of terrain area. That we cannot able to say. Either it has to belongs to water or it has to belongs to the terrain area. So there should not be any common pattern between these two things. The data set we are discussing, the data set should be comprising of summation of all the cluster. Means if we are dividing a particular image into various cluster or various segments, then the summation of all those parts is equal to the entire data set. That means the different portions we have broken it down, the image, if we add all of those, then that will make out the entire image. So these three conditions we have to consider while doing an image partition or an image segmentation. One of the very popular algorithm which can easily be applied over here is k-means clustering algorithm, which is effective for the image segmentation best thing. So with k-means algorithm, what we do is, suppose this particular data we have to partition them into two different parts. Then what we will do is randomly take two initial center points, then calculate the distance of each point to this red center and to its yellow center. Okay. So this red triangle and yellow triangle you can observe. I am calculating each point distance from this red triangle and from this yellow triangle, and thereby bifurcated all of them into two different parts. You observe that these red points have become one particular group and these yellow points have now become another particular group. The entire data is bifurcated into two different parts. Okay. Now after this, the red point will move to the mean of this particular area, and the yellow triangle will try to move to the mean of this particular group. So thereby it is known as k-means clustering. K stands for how many group you are dividing the data. Over here you observe that this red triangle now moved to this particular point and the yellow triangle has moved to this particular point, that is representing the mean or average of the thing. So with the progress of iteration, now these centers are gradually moving from one point to the other, one point to the other, until and unless the portion become fixed. So once the portion become fixed, you observe that these red points and yellow points have been effectively bifurcated into two different groups or two different segments. So I told you that distance minimization, it becomes easily to separate these points. While the popular distance that are used are Manhattan distance, the popular Euclidean distance. Everyone knows about the Euclidean distance. Manhattan distance is another form. So to update these cluster centers, we are using the mean of the thing, mean of the patterns or average of the patterns. So that's why it is known as the k-means clustering algorithm, to update the center of the clusters. Over here you observe that an example is taken like Eastern Arizona image in there is a forest fire and at eastern Arizona in 2016, and it is divided into 4 different clusters with the K-means based image segmentation. In one cluster you observe that the entire smoke is there. This is the original image. Original hyperspectral image is this one, and in the first image this smoke region is there. In the second image you can see the fire portion is identified. In the third portion only the greenery area is available, and in the fourth portion only the terrain region information is available. Similarly, an Epstol Islands image taken on 2015 is bifurcated into 2 different segments. One segment is representing the entire portion of the land, and another portion is divided into the pixels with various depth of water. So this can be further classified into many different portions, as you can able to observe that different colors of the water is representing the different depths also. The data clustering thus formulated as an optimization problem. Here I am relating the image segmentation as a data clustering problem, and data clustering can be viewed as an optimization problem. That means we are optimizing a function f which is representing a relationship between the data or the image with respect to the cluster center. So Zi is my cluster center or the pixel segments center, and I want to relate a function between all data points or all the pixel of the image to the corresponding cluster centers. So if I can able to maximize or minimize this particular function, then I can able to achieve the different partitions of this particular image. With K-means clustering algorithm, this optimization is known as the minimization of Euclidean distance. So this problem is formulated as minimization of this f1, that is minimization of the Euclidean distance associated with the problem. All of you know about the single and multi-objective optimization that have already been discussed, that in place instead of one particular optima, if you will have more number of optimas, then your objective is to determine the global optima, and there you face the problem with the derivative based optimization algorithm or hill climbing based algorithm. Okay, they will try to find out the local maximas, but our objective is not to reach to this local maximum but to reach to the global maxima. So instead of going for the standard benchmark methods that have already been discussed, like yesterday I discussed about least mean square algorithm, steepest descent algorithm, and many other algorithms, we are going for the nature inspired optimization algorithm which will easily solve this particular problem. And you observe that in this particular multimodal problem where we need to determine this global maxima, here we have taken many elements, and these elements can be birds, ants, various molecules, various creatures which interact among themselves and do collaborative learning so that they can reach to this particular global optimal solution. Maybe some of them may stock in the local, but ultimately they all will try to migrate to this particular global optima point. So you can able to observe that there are many multimodal benchmark functions like this: egg holder, drop wave, alpine, Greenwick, Rastrigian function, de Jong function. All these have several maxima and several minima. So to find out the global optima in such case is a really challenging problem. And researchers have developed several algorithms over the years which have been used for solving these type of problems. So various nature inspired algorithms like the evolutionary algorithm, Professor Kusumdeep discussed about the genetic algorithm. Okay, genetic algorithm developed by John Holland in 1975. And these algorithms have been used for the cluster analysis in 1994, you observe. Then there is whether you are optimizing one particular function or more than one particular function, two functions, three functions, like that, many functions. If you are optimizing, then that will becomes a multi-objective type of problem. And Professor Sanghamitra Bandyopadhyay applied this particular multi-objective version of this algorithm NSGA2. Also, it will be discussed in the future in this particular FDP. Like that, there are many other algorithms you observe. Evolutionary algorithms, these are known as evolutionary algorithms. Why? Because from evolution, from parents to the next generation to the next generation, the things will be evolved. Okay, and every time the solutions becomes better, the next generation children will become better, like the genetic algorithms. So once from the initial solution, the final solution will definitely become better, and these solutions cannot become worse than the original one. So like that, there are various physical algorithms are there, which we will be also discussing in our course. These physical algorithms are simulated annealing, like memetic algorithm, many other algorithms. These algorithms are based on, inspired from the physical phenomenon, like heating cooling process of a particular system, how it is related to an optimization problem, how it can be solved, how the problem formulation have been carried out, how the optimization algorithms have been inspired out of these phenomena. So that will be discussed. Swarm intelligence, already the particle swarm optimization and ant colony optimization is discussed with you. It is not just one individual job, but it is a group's behavior, a group of pool of agents, and their collective behavior is responsible for swarm intelligence. Collective behavior for search for food, like a group of ants, they are together searching for the food for the sugar particles. Like that, the particle swarm optimization, a group of fishes or a group of birds searching for the particular food. How their collective behavior is mimicked in the form of an algorithm, that is swarm intelligence. Similarly, there are bio-inspired algorithms, like various biological functions are there from which the algorithms have been derived, which can be mimicking the functional behavior and helping us to achieve the solve the optimization problem. The popular algorithms are artificial immune system, the bacterial foraging optimization algorithm, and like that, many other optimization algorithms over here you observe. These all algorithms have used for the cluster analysis in single objective and multi-objective mode for analysis. There are other nature inspired algorithms also reported by various researchers from various phenomena. And you observe that all these algorithms, the primary algorithms, I can able to say genetic algorithm, differential evolution will be discussed tomorrow, ant colony optimization, particle swarm optimization, artificial bee colony will be discussed tomorrow, and this immune system based algorithm, all of them follows an iterative process. All these follows a iterative process. Look, the genetic algorithm discussed today is initialize chromosome, crossover, mutation, fitness evaluation, selection, and it is an iterative process with a number of population, and that will give you the output. the resultant output. And like that, every algorithm has different steps, different ways of approach to solve a particular problem. So like I told you, distance minimization between the points and the pixel values, that is one particular criteria to solve such a problem. So there are various other statistical functions are there which will help us. Just a minute. To do the analysis of the image, like the midroid distance minimization, the centroid distance minimization. There is variance ratio criterion, whose maximization will give us the effective segregation, intra and intra-cluster distance, the Dunes index maximization, David Borden index minimization. So some of these statistical functions, either maximization or minimization, will give us effective partitioning or effective segmentation or effective clustering of the particular images. So these are mainly used for the fitness evaluation or as cluster validity index or the fitness function for the partitioning. So you can refer to this particular survey article of the nature inspired meta heuristic for the partitional clustering, and this I have written on 2014, and till date it has got more than 650 citations, single paper got. And in this particular research paper I have given a lot of examples of, it is a collection of around 400 research articles which summarizes the application of various nature inspired algorithms for this particular application. So the next important thing is this social spider optimization algorithm, which is inspired from the behavior of spider. Okay. So what is important about these spiders and how the algorithm from mimicking the behavior of the spider is inspired? So it is based on a lot of spiders taken together. Okay, they formulate a swarm. Okay, and in this particular spider family, it is a multi-agent algorithm. Okay, many times you would have heard about in the swarm intelligence that multi-agent systems. Multi-agent system means what? In if you are taking particle swarm optimization, all of them are particles, only particles. They are weight update equations, all the particles remain same. Whereas in multi-agent system or multi-agent algorithms, all of them will have different segments. Means if you are taking 10 particles, there will be bifurcation. Some of the particles will change their weight in one particular way, some other particles will change their thing in another way. So over here there are two different agents. You observe there is a male and female spiders. So this entire spider population you will take, that will behave in two different ways. One is male spider's behavior is different, female spider behavior is different. So thereby the algorithm is defined in such a way that the entire population 20 or 30 if you are taking, they will be bifurcated into two different manner. And the bifurcation will happen in such a way. You observe that here I am giving you an example. I have designed a wave. In this particular wave there are three different type of spiders I have defined. Okay, one particular is male. You see it is a swarm of spiders on this particular wave. One is this big particular one is a female spider. Okay, another one is a male spider. The male is again bifurcated into two parts. One is dominant male and another one is non-dominant male, and another one is baby spider. Why so many spiders, different type we are taking? Because each of them has their own role to do help in the update equation. Okay, a good meta heuristic algorithm should always have a balance between local search and global search. Okay, that local search means what? It is exploitation of search space, and global search means what? Exploration of search space. That means the entire search space you want to search. That is one objective, and second objective is in a specific location you want deeper search. That is another objective. So a good algorithm will always balance between two things. A good evolutionary algorithm will balance these two things. One is search space entire exploration, second thing is a deep search inside a particular location. So that's why there are a lot of search agents have been put over here. Okay, so the search agents are bifurcated in these two particular part. One is 60 to 90% of the spider populations are termed as females. So we assume that 70% over here have been taken as females and 30% are males. Okay, swarm size is constant. That means if we are initializing 30 or 40, suppose 40 population we have initialized, that means to the end there will be only 40 population. Every iteration the number of population will remain same for this algorithm. Then there are some parameter constants which we will be discussing with this. So how we are proceeding with the algorithm? So initially we have to take 70% as female spider and then 30% as male spiders. Okay. So if I am considering 100 as population, then 70 are female and 30 are male spiders. Then each spider location over here is representing one cluster center. Okay, if I have to partition an image into three different partitions, then each partition's center is represented with one particular spider. So like that there will be number of spiders I will be considering. There may be 100 spiders, then each spider is representing three cluster centers. Then which particular spider is good, or which particular one is a strong one, or which particular one is a weak one, that we can able to determine with the fitness evaluation. What is the fitness evaluation? The fitness evaluation means in our problem whether the segments obtained with the clustering process, it is a better segmented one or it is a worst segmented one. If the clusters are perfectly aligned, then that is a better one. If they are not perfectly aligned or they are in a haphazard manner, they do not convey significant meaning, that means it is not of so much use. So then the fitness function, we can say it is not a good one. Okay, so over here minimization of Euclidean distance between the data points to the cluster center. Okay, and the each spider position represents the cluster center nodes. So that's one between the spider and the data points, the spider representing the cluster center and all the data points to the particular image. Between them the distance we are trying to minimize. Then we have to assign, as per the algorithm flow, we have to assign some weights to the spider. These weights are based on the fitness function associated with the spider. So you would see that a normalized form of the fitness function of the spider is considered as weight. So over here the algorithm says that a spider with higher weight, okay, that we consider as a good spider. So the spider whose fitness function is better or who is giving us good clusters, that is treated as a best solution. Okay, and if a spider is not giving us good clustering result, that is not that one has lower weight or that is a lower fit spider. Okay, then the entire spider population, male spider population, those 30 male spiders whose weights are more than the median weight of it, they we are considering them as dominant spiders, and otherwise it is known as non-dominant spiders. So first we have divided them into three particular things. One is female spider and male spider. Female are 70, male are 30. So out of the 30, again we are based upon their weight, we are segregating them into two parts. One is dominant male, another one is non-dominant male. So in this particular thing, total population is bifurcated into three different portions. Now how the distance, how this particular algorithm is different than that of the PSO. I am saying here also we have a local spider and a global spider position, like PSO has a local best and a global best. Over here also we have a local spider and we have a global spider, whom we will say as global spider, whose weight is higher, or which is the most fitted among the 100. If there are 100 things, out of the 100 whose weight is very high or whose fitness is very high, that one is the global spider. And local spider means which is near to me or based upon the distance which is close, that is a local spider. So what is the difference? How this is different than the PSO? Here you observe that the update equation, you just have a look over here. The update equations in this particular algorithm, the update equation in this particular algorithm is like this. If random number is less than a percentage factor, it will be like this, and this is another sort of equation otherwise. So look, the female spider weight update over here is dependent upon these two equations. The only difference between these two equations is upper part there is only positive positive and lower part only negative negative. Okay, so in one case the spider is moving ahead, in other case the spider is moving back. And over here in both the equation you look that there is a component of the global component and another is a local component. Okay, and here the interesting thing is this particular thing V into SG minus SF, this particular component is a non-linear one. It is not linear like PSO, but it is a non-linear one. What do you mean by non-linear one? You observe that this particular one is e to the power minus SISG square. So this is like a weighted, it is inspired from if a weight of a particular spider is very heavy, that will punch this particular wave, and when it will punch, then the thing will be reflected on the wave. That means the spider which is at the end of the particular wave can also able to listen to the highest weighted spider, and once the punching is there on the wave, that will generate a pulse, and that pulse will gradually ripple down to the end of the wave. That means suppose here you assume it as a curve, here the biggest spider in the wave or most weighted spider has put a punch, then it generated a signal like this, and that signal is gradually slowly decreasing and reaching to the end, and this is exponentially decaying factor. So exponentially this behavior is slowly decaying, you observe exponentially decaying. So e to the power minus x, so exponentially decaying component, a nonlinear component is associated with the global and local update equation. So the weight update equations are like that considers non-linearity into account. It is not linear vectors which are getting added, but there are non-linear components are also involved in this particular update equation. So this is how the female spider weight update happens. You observe that it is updated based upon three components. One is the global global thing whose weight is highest, and the local thing which is close to it, and a random number. Why a random number is always considered? Because we do not want to go and collide with another spider. We want to go to nearby to that particular one. So these three components, non-linear components, is getting added and the spider is moving. Okay, so it can move forward or it can move backward, depends upon this random number. If it is lower than this probability factor, so the probability factor is suppose 0.7, then if a random number I have generated between 0 to 1, if it is lower than 0.7, then it will take care of upper part of the equation, otherwise it will take care of the lower part of the equation. So this is how the female spider movements happen. That means out of 100 population, 70 spiders will follow this particular procedure for weight update using these two equations. Then there are rest 30 spiders are there. Among the 30, we have bifurcated again them into two different type of spider. One is dominant male and another one is non-dominant male. So for dominant male spider, you observe that their update equation is different than that of the female spiders. So these particular dominant male spiders, they have this nonlinearity equations, but their movement is towards the female spiders only. So if you are saying that about 30 spiders are there, so their attraction towards only towards the female spider, and that difference they try to minimize, or they try to move towards a global optimal hub towards that. So that's how the update equation of her mating purpose, this particular dominant male spider movement happens like this. It also depends upon the three vectors. One vector is dragging it towards the female spider movement, and another one is this random number. So these two components are dragging this particular one. Then the third one is non-dominant male spider movement. That is very important from the exploitation point of view of the algorithm. So the female spider movement is generally responsible for the exploration. The dominant male also partially the exploration, but the exploitation happens with the non-dominant spider movements. So with this, the average weight of the spider is taken into account, and from it the difference of the non-dominant spider is taken into account, and that's moved towards that. So in a particular location on the wave, they all try to search deeper in a point. Whichever is the global solution, to that one more solutions will try to deeper search into the global point. So thereby the exploration happens with the non-dominant male spiders movements. And they move slowly, but they deep digger. So next procedure in this particular algorithm is a mating procedure. In which so just a minute. In this particular procedure, the mating happens between the parent spiders, and baby spiders gets born. So the mating process is formulated like this, that always remember that there are more female spiders. So there are 3 female spiders are there and 1 male spider is there, and this is suppose their position in the algorithm. Position means the cluster centers, means the pixel centers, pixel central value, and this is their fitness function, that means their weights. Okay, so if you will observe that this is the corresponding spider weights, so if we will make it summation of all these weights, Summation of all these weights is equal to 1.490. Now what is the contribution of this particular S1 spider on this entire thing? That is the probability. So 0.4 divided by 1.49 is 0.26. Similarly 0.3 divided by 1.49 is 0.19. So like that these all four probability we have calculated. So from this we observe that the probability of this third spider is highest, 0.36. 0.36 or 36%. So this particular spider probability is very high, that is the female spider too probability is very high and 36%. So the baby spider which will be produced, that will take the position and the weight of this mother. Okay, so you observe that the new spider that is produced, that is taking care of the best segmented spider, that is the mother's position it has captured. Okay, so among many spiders, so the best solution is again producing further new solutions to move ahead. So always the solutions will become much better. In the original social spider algorithm, you observe that there are three processes. One is this female update position update, another one is dominant male position update, another one is the non-dominant male position update. So these all three were happening sequentially, and there is mating operation also between the female and dominant male position. So with this the entire process was carrying out. But we proposed another algorithm in which this non-dominant and these three operations, female position update, dominant male position update and non-dominant male position update, all three have been carried out in parallel manner. Parallel. So if we are making them parallel, then it is termed as a parallel social spider algorithm. So these three things, when we execute them parallelly, then it will reduce the computational complexity of the algorithm, or you can execute the algorithm in a very fast manner. So over here we have tested this particular one for the cluster analysis on various data sets like small dimensional data sets as well as large dimensional data sets in which there are various classes. You observe that this particular KKD COP data set, it has 1,45,741 observation with 10 different class with 74 attributes. Large data set also we have taken, as well as small data sets also we have taken, and we have compared the performance of this algorithm with that of genetic algorithm, k-means clustering algorithm, particle swarm optimization you have observed, and this bee colony algorithm Professor Jagdish Bansal will teach you in the course of the time in this faculty development program. And we have observed that the classification error percentage we have measured, and in some of the cases our classification error percentage is lower than some of the algorithms, and sometimes better than all of the algorithms, but sometimes not. Okay, out of the 9 data sets. So in the KKD COP data set, you observe that this proposed algorithm result is very good, because the partitions that have been obtained, they are not overlapping with each other, but there are distinct portions. So if you will observe, these are non-overlapping in nature, whereas in other things there is much overlapping areas are there, much overlapping things are there, and that is not a very good one. I told you while designing the parallel version of the algorithm, it is giving better than the original algorithm in terms of computational saving. Computational percentage saving, you observe that it is giving us the effective timing is lower like compared to 44 seconds, the algorithm is taking 25 seconds for this data set. Compared to 35 seconds, it is giving 25 seconds. So computational time is getting reduced by designing the parallel version of the algorithm. Then we applied this one to the hyperspectral imaging of a flood affected area of Chennai. There is a flood in Chennai in 2015, October 21. This is the image captured before the flood, and this is December 8, 2015, after the flood. So you observe that we have segmented this particular image and try to find out what is the water retention in this particular image, water content in the particular image that we extracted. So water retention after flood, you can easily able to observe that here these lakes and this river bank that has increased near the seashore. There are a lot of water content over here, and if you can timely able to observe this particular thing, you can inform the authority to evacuate the peoples which are staying very close to this particular region. Okay, so this is one very important application of the hyperspectral image analysis. And the second important problem along with the image segmentation is band selection. So this particular is hyperspectral image, because of it is a bunch of images, we cannot able to process them effectively because there is huge amount of computational burden. One image will be of more than 10 GB. So it is very difficult to process the entire image. So that's why at times we have to use band selection mechanism to reduce the number of bands. That means from a large number of bands, suppose there are 100 bands over here, so out of the 100 bands, may not be all will be useful for us, but some may be useful. So which are our useful bands and which are not? So out of 100 bands, if we can select only 20 bands which are useful for us, then this 10 GB of data will come down to maybe half a GB or 2 GB or 1 GB. Then less than 1 GB data, it is easier for us to process. The computational complexity on our GPU will come lower, so that we can do effective processing and the cluster analysis for effective data analysis. So we have to reduce the number of bands from this large spectral image to the lower image. So how to effectively do the band selection? Hyperspectral imaging band selection can also be formulated as an optimization problem over here. So the objectives for this band selection have been taken is one particular objective is variance of the fast spectral derivative. One particular function which we are taking the variance of the fast spectral derivative, we are trying to determine the minimum value of this dij function. Okay, its minimization will give us the better bands in terms of similarity. Similarly, another minimization problem can be taken as entropy measure, entropy between different bands. If we are trying to minimize the uncertainty between the selected bands, then we have to minimize the entropy. Then coefficient of variation, another very important formulation which can be minimized with the particular band. Okay, so this is these are the objectives can be taken for effective band selection out of the hyperspectral imaging. And this particular algorithm also we are going to discuss in detail is a many objective optimization algorithm by Professor Kalyan Moedev, who is presently at Michigan State University, USA, and earlier he was there at IIT Kanpur. Okay, this is his Michigan State University link and this is his IIT Kanpur link. So you can refer this particular important websites, and this particular NSGA3 algorithm also we are going to cover in our FDP, and it will be a many objective optimization algorithm. So I told you in this particular problem there are three objectives we are taking simultaneously to do the band selection, so that the band selection becomes very effective in the particular thing. So over here I want to show you some results that out of these 100 bands, there are very few bands which are highlighted in white color, they have been selected. So you observe that with binary and SGA3, very less number of bands have been selected out of 100 bands. So like that you observe, and the with various other algorithms also the performance have been compared, that how many effective bands we can able to take for the particular image. And this is the image cluster analysis after the band selection of the Pavia University dataset, in which there are buildings are there are greenery areas is there. This is the ground truth of the image, and this is the obtained segmented image with the algorithm. So like that the analysis can be done. And so I have told you about two important problem formulation, and you can go through our websites for the further publications on this particular domain. Okay, and many good journals our group have cracked in last several years on this particular applications. So now you can able to ask me questions on it. So if you have any query, you can ask me, participants. You can type in the chat box. So one particular researcher has told that is interested in nature-inspired algorithm for k-means clustering in image processing. There are various articles are there, and as a beginner, so if you are using MATLAB and Python, I can able to say that you should go through the k-means based image segmentation. Both packages are there in MATLAB as well as in Python. So you can explore those packages, and easily you can take the any benchmark image and try to use those packages and try to get the output. And one particular research paper I have told you, that is I have shown in the slide, that one is telling the basics about the clustering algorithm, and very fundamentally how these algorithms can be used is written by me. So many researchers are following that one, so you can also follow that particular one. On what basis the number of bands are selected? The bands are selected based upon their unsimilarity between the various bands. Means if between bands, if there is a lot of similarity, we are trying to eliminate those bands, and those things will be based upon the criteria set by various criteria obtained with the three conditions I have told, three objective functions I have told. Yeah, MATLAB has already has the packages for genetic algorithm, particle swarm optimization. The MATLAB packages are there already. we will show you those packages also. Um, So this particular talk is already recorded and available in the YouTube. So those who wish to look at the research papers and the concepts regarding this, that already I have shown in the video. So you can able to see those all references and go through them. And the particular paper I told you on Elsevier, that nature-inspired meta-heuristic algorithms for the data clustering, that also you can able to refer the review article. So I again request all the participants to go through that mock quiz so that we will have an idea that at least you are able to appear for the quiz. So please go through that mock quiz that will be there for more than 24 hours. So anytime you can log in the Canvas and just give that mock quiz. That quiz marks will not be counted for you. It will not be counted, but it is just a mock quiz we are accessing so that we can able to know that you can able to appear for the quiz. So I request all of you to do that one in the Canvas. So as there is no further questions in this particular session, so I hereby announce to close the session for today. So thank you all.